To solve this question, we want to notice that it's actually a Roman numeral question. So we treat it slightly different than the other problem solving questions. The kind of structure of solving these is a little bit more involved. The answer choices are not like normal problem solving questions where they have values. The answer choices are actually different combinations of these Roman numeral statements here. So the question typically asks us, or this question specifically asks us, if x is less than 0, which of the following statements must decrease as x decreases? So this must is kind of a really key word here. And we're looking for, out of all of the possible statements, which ones must decrease as x decreases. So the answer choice is not just going to be a single statement. We could have multiple statements that actually satisfy this question. So when we're going through, the best kind of method to go through is to kind of start with our statement 1, see if that satisfies our question, and whether it's included in our answer or not, and then move on to statement 2 and do the same as statement 3. And as we're going through and verifying whether the statements work for our question, we want to eliminate our answer choices as we go if we can. So let's go ahead and let's think about our question. We're told that x is less than 0. And our first statement here, we're kind of trying to figure out whether 10x minus 100 will decrease as x decreases, whether it must decrease as x decreases. So x less than 0 actually corresponds to a number line, and it's kind of better if we just have a quick number line for us. We're not including 0. So x is anything over here. Now that means that if we're going to pick values for x, so test values for x, which is a common technique to use for these, probably the most fast way or the fastest way to arrive at whether it decreases or not is to pick values for x. And when we're picking values for x, all of them are going to be negative here because of our restriction, but we don't want to forget about fraction values because sometimes those can kind of mess us up as we're looking for patterns happening to answer our question. So we do want to consider as we're testing values like negative a half, negative 1, and then like any other value like negative 2. Kind of easy, kind of simple values as we're going through. So let's go ahead and let's start with something close to 0, and as x decreases, we'll see whether this result is decreasing. So first let's choose x equal to negative a half, and let's plug that in. If x is negative a half, then we have 10 times negative a half minus 100. And if we simplify this, we have 10 times negative a half gives us negative 5 minus 100, and that's negative 105. So we're going to go ahead and keep decreasing x, and we're looking for whether this result is going to decrease as well. And that would give us a nice pattern to go off of. So if x is, let's pick a convenient value, negative 1, something less than the one before it. 10 times negative 1 minus 100 equals negative 10 minus 100, so negative 110. And this seems to be decreasing. So if we have time, if we're running out of time, we wouldn't try a third one. But if we have time, we would try a third one just to kind of verify the pattern here. Plugging in negative 2 to this, we'll get a negative 20 minus 100, and we get a negative 120. And that's definitely a good pattern to conclude that, yes, this would be decreasing. And it's really crucial to remember that it must decrease as x decreases. So x is decreasing here, and this value is also decreasing. So the answer would be yes. And this statement alone would be sufficient. Or not sufficient, but it would be decreasing. So we would want to count it in our answer choices. So if we look at our answer choices, we need an answer choice that includes statement 1. So right off the bat, we can eliminate choice B and E because neither of those include statement 1 in the answer choice. So we are still left with A, C, and D, and so we're going to go ahead and check statement 2 and see what happens there, whether it's decreasing or not. So let's go ahead and just clear our board to create some space for ourselves. And we'll go ahead and take a look at statement 2. So statement 2 looks a little bit more involved, and we kind of want to tell kind of the same, we can use the same logic as we did for statement 1 and pick some values for x. And remember, it's as x decreases, is this product, or is this quotient that we're given for statement 2 going to decrease as well? And again, we're looking for a pattern. So a good pattern going will be enough for us. So let's go ahead and let's check x equal to, let's pick kind of a small value. We could pick -1/2 again, something close to 0. We don't want to forget about fractions. So picking -1/2, we can plug in and we end up with a -1/2 minus 1 over -1/2. Simplifying this in the top, we end up with -3/2 divided by -1/2. And simplifying this, we end up with a 3. Flipping the fractions, the negatives cancel, and if we flip the denominator, change our division to multiplication, multiply by the reciprocal of the denominator, then we would cancel the 2's and be left with a positive 3. And let's see what happens as we decrease x. So our next step would be to check -1, and let's plug in. So -1 minus 1 over -1. Simplifying this, we have a -2 over -1, and that results in a positive 2. So far it looks like it's decreasing, and again, if we were running out of time, we would probably kind of conclude, yes, it's decreasing. But for good measure, if we have the time, we'd check one more and plug in, so -2 minus 1 over -2. Simplifying a little bit, we end up with a -3 over -2. And simplifying, we can cancel the negatives. We could actually write this as a mixed number just because it's easier to compare. We'd have positive 1.5. This does seem to be decreasing. So if we are decreasing, as x is decreasing, right, we made sure to pick values in a decreasing manner. As x decreases, this is also decreasing. So this is enough to say, yes, this is decreasing as x decreases. Now, it's not kind of an abstract proof of it, obviously, but picking answer choices on the Gmat is a nice kind of quick way to notice our patterns here, and that's what we're looking for. So yes, we would say statement 2 is also satisfied. So when we take a look at our answer choices, we need to exclude any value that doesn't include statement 2. Choice A doesn't include statement 2, so we can eliminate that. And choice D also doesn't include statement 2, so we can eliminate that. So the final answer choice is choice C. 1 and 2, statements 1 and 2 actually work and satisfy this question. This means that we didn't check statement 3, but we actually didn't need to here because we were able to use our eliminating answer choices as we go through our work, and we got down to one answer choice before we needed to check statement 3. Sometimes that happens, and it saves some time, and we wouldn't actually need to go in and do that extra work, which is why eliminating answer choices as we go through our work saves us time in the end. So our final answer choice is answer choice C. Statements 1 and 2 will work for us.